Okay, so the last lesson in chapter 8 we're going to do is called solving radical equations. And when you're solving radical equations, there's one step that you must adhere to regardless of the situation it is, and you must do this first. Number 1. First step always. You have to isolate the radical. So what does it mean to isolate something? Get it by itself. Okay? So whenever there's just one radical in a problem, okay, this is problem has one radical. Okay? We want to get it by itself. So what do I need to do in this problem to get the radical by itself? Okay, we need to get rid of the 5 first. And this is the biggest problem that you will run into is if you do not isolate the radical first, you will have errors. And we don't like errors, so. All right, so we'll subtract 5 from both sides. So we get the square root of x plus 1 equals 11. Okay, so I've isolated the radical. So now what do I do? Okay, now, we say we're going to square both sides, okay? Right? But in reality, what we're going to do is we're going to raise both sides to the power of the index. Okay? The reason I say that is because we're not just dealing with square roots anymore, right? We looked at cube roots and fourth roots and fifth roots. And so regardless of the situation, we're going to raise both sides to the power of the index. So in this case, the index is a 2. So we're going to square both sides. So we get x plus 1 equals 121. So x equals 120. Okay. And make sure you check your answer. Okay. All right, let's see. If I put 120 in here, we get a square root of 121, which is 11, and 5 plus 11 is 16, okay? All right, checked it. Mentally did it. Okay, it works. Okay? But you need to remember to check it, because we're going to run into situations where if you don't, you're in trouble. All right, letter B. Seven times the cube root of 5x minus 7 equals 84. So there's one radical in this problem. So the first thing I need to do is isolate the radical. So Austin, what do I need to do? McCumber? We want to divide by 7. That's right. So we get the cube root of 5x minus 7 equals 12. All right, so we've isolated the radical. So step 2, raise both sides to the power of the index. And the index in this case is 3. So we're going to cube both sides. So we get 5x minus 7 equals 1,728. Right. So we add 7 to that. $1,735, and then divide by 5. What is it? 347. Okay. All right, well, this one's a little bit tougher to check then. So I'll take out my calculator. Let me see, I'm going to write it down first. So I had 7 times the cube root of 5 times 347 minus 7. Does that equal 84? All right, so all I did is replace x with my answer. So 7, where's the cube root at? Okay, under math, and number 4 is cube root. 5 times 347 minus 7, and that equals 84. Okay. So I did it right. That's always a good thing. Let's do A and B. All right, so if there's one radical, then we want to isolate the radical first, okay, always. If there's 2 radicals, okay, if there's 2 radicals in an equation, the first thing we want to do is get them on opposite sides of the equal sign. Okay. First thing is get them on the opposite sides of the equal sign. Okay, this is great. They are. Two radicals, opposite sides, equal sign. What's step 2 then? Okay. Square both sides in this case, or raise them to the power of the index. Okay? All right. Square both sides or raise the power of the index. All right. So radicals are on both sides, so we need to, in this case, square both sides. Now, this is a little bit trickier because we have that 3 in front of the radical on the right-hand side. So on the left-hand side, the square root and the squared, they undo each other. So we have 7x plus 2 on the left. On the right, we also have the 3x minus 2 because that square is going to eliminate that radical. But what do I have to do with the 3? Yep, you have to square the 3. And so it becomes 9 times that quantity. It's 9 times the quantity. So we have to distribute the 9 before we can solve the equation then. All right, and then it just becomes a simple equation with a variable on both sides. Something you've done many of before. So we'll subtract 7x and add 18. and you need to make sure that you do check your answer. Put 1 in for x. On the left side, we get the square root of 7 times 1, which is 7, plus 2. So we have the square root of 9 on the left. Oops. And on the right, we get 3 times the square root of 1, right? 3 times 1 is 3 minus 2. And so 3 equals 3. Okay. So if we have radicals, or more than one radical, or two radicals in an equation, we want to get the radicals on opposite sides, first of all. Okay, oh, this isn't even that situation, is it? Let's get rid of that. That doesn't apply. So we have one radical. Is it isolated? All right. So what are we going to do then? Okay, we're going to square both sides. So on the left, I get negative 3x plus 33. And on the right, I get 25 minus 10x plus x squared. Right, Spencer? That's not 25 minus x squared, is it? How did I get 25 minus 10x plus x squared? Did what? I had to FOIL it. Don't forget to do that. All right, that's 5 minus x times 5 minus x. It's a perfect square trinomial, things that we've talked lots about. A minus b, that quantity squared, is equal to that. A squared, the 5 is a, so that would be 25. 2 times a times b. 2 times 5 times x is 10x. And then b squared would be x squared. Right? So what kind of an equation do I have now? Is it linear? It's quadratic. What am I supposed to do when I have a quadratic equation? Okay. Get everything on the same side so it's equal to 0, so hopefully I can factor it. Okay. So the x squared is positive on the right-hand side, so that means I want to get everything over there with it. So I'm going to add 3x and subtract 33. So we get 0 equals. And then I'm going to write it in standard form to make it easier to factor. X squared minus 7x minus 8. Then we factor. In this case, we get x minus 8 and x plus 1. So we get x equals positive 8 or negative 1. So we need to check them. Let's bring this down here. All right, so we can see it to check it. I'm sure that's why I had it there. All right, so square root of negative 3 times 8 plus 33 equals 5 minus x. Oops, 5 minus 8. I have a problem, don't I? Okay. I can't take the square root and get a negative number. Okay. So when I simplify this, we get negative 24 plus 33 is square root of 9, which is positive 3, but that is not equal to negative 3. So 8 is extraneous. Okay? And the solution that we get does not work. So 8 does not work. All right, let's try 1, or negative 1. So let's see, we get square root of 36, which is 6, and yes, that does equal 6. So x equals 1 is my answer. Or negative 1. So when you're solving those, you have to make sure you check your answer, because we can't take the square root and get a negative number. Okay. One more. Now, example 4 here is just like the ones we just did, right? The only difference is they have a rational exponent instead of a radical. We looked at rational exponents, didn't we? Okay. The denominator of the rational exponent is what part of the radical? It's the index. Okay. The denominator of the rational exponent is the index. Okay. So in this case, the index is 3. And so I'm going to raise both sides to the third power to start. So this is exactly like the first example we did. It's just they have a rational exponent instead of a... So we get 5x plus 7 equals 27. Subtract 7, we get 5x equals 20, so x equals 4. If I checked it, 5 times 4 is 20, plus 7 is 27, and the cube root of 27 is 3. So it works. So you could, if you don't like having to deal with a fractional exponent, you don't like what it looks like, then change it. I could rewrite that as the square root of 4x plus 8. That makes more sense to start with. Then go ahead and do that. Because now, what's my index again? 2. So I have to square both sides. So you could do it either way. Either way, you're doing the raising it to the power of 2. So we get everything together. The quadratic, so I need to get it equal to 0. I have a coefficient of x squared. I don't like factoring with coefficients of x squared. It's harder. So can I do anything here to simplify that? Okay, I can divide everything by 4. Much easier. Okay, and factor it. And we get positive 2 and negative 1. But can't forget the most important thing. Even though I got an answer, doesn't mean anything. Need to check it. I already know which one's not going to work, which one's not going to work. Okay? Negative 1 isn't, because when I do 4x plus 8, the square root of that, I'm going to get a positive number. When I put negative 1 in for x, negative. So this doesn't work. So my answer is x equals 2. Okay. Now, I want to make sure that's true. Spencer, what can I do? I could plug it in, or I have this handy dandy thing called a calculator. And I could actually go to my y equals, put 2x on the left side, and parentheses, 4x plus 8 on the right, raise it to the power of 1/2 or 0.5. Graph them, and they intersect in how many different places? 1. And I'll bet that place is when x equals 2. Okay. So even though we get 2 answers, you have to remember to check your answers. And if I was to graph both sides of those equations, I could still find them by finding the intersection point.